also pay attention to this one. So as far as we'll just start at 8 and the copy center does not work, so what you will do, you will take your copybooks, open it, and as soon as we'll start with the internal structure of spinal cord, I will use blackboard to draw. Yes, you will use your copybooks. Do you have copybooks? I hope so. Yes, and after break, you have time today. You will repeat the same, but already with this copy that will be obtained during break from the copy center. Okay, because everybody should have it. Everybody should have it. But it's even better that now you don't have, because you will do it perfectly with this copy, but as the draft it will be in your copybook now. But before internal structure, of course, we'll talk a little bit about external anatomy of spinal cord. And actually, you see, different parts of brain are also described by the certain plan. To start with external anatomy, afterwards we'll talk about internal anatomy, and of course functions. Spinal cord is a tubular structure, yes, located inside the vertebral column, and exactly 1 year ago, you remember, vertebrae were described. It starts from the place of the foramen magnum. Foramen magnum is the opening in the occipital bone. The end of spinal cord depends on the age. What does it mean? If it's adult person, the end of spinal cord is located at the level of the second lumbar vertebra. But if it's newborn, you see it's below the level of the third and even fourth lumbar vertebra. Why? Because during embryogenesis, the speed of growth of vertebral column is in front of the speed of growth of spinal cord. So spinal cord is a little bit retarded, delayed. So therefore, if it's newborn, their length, the length of spinal cord and vertebral column is nearly equal to each other. But if it's adult, the spinal cord looks shorter in comparison with the length of vertebral column. It's important also for surgeons to know where is the end of spinal cord, the second lumbar vertebra. Because if the surgeon needs to take cerebrospinal fluid from the spaces between the meninges of spinal cord, it's important to use special needle, of course, and to take the fluid below the level of the spinal cord. It's logically to not damage, of course, to not damage spinal cord. And therefore, the knowledge on the end of spinal cord, that is the second lumbar vertebra, if it's adult, yes? We understand that the cerebrospinal fluid can be taken 1 vertebra below, so the level of the third lumbar vertebra. It's terminated for adult at the level of the second lumbar vertebra. What else? We can see that the spinal cord does not have equal diameter, and it has some enlargements. One enlargement is located in the cervical region, and it's called the cervical enlargement. The term for enlargement is the intumescentia. The cervical intumescentia is located here. This enlargement is very well differentiated because upper limbs get innervation from this enlargement. The second enlargement is called lumbosacral. Intumescentia lumbosacralis, lumbosacral enlargement. this enlargement is less differentiated, but it's bigger, because from this enlargement the lower limbs are innervated. So there are two enlargements. We have the surface of the spinal cord. It's not very evident here, but we can compare with these. For example, for these pictures, and the part of spinal cord is demonstrated there. You see that there is the anterior surface, and this surface has the deep groove, and this deep groove is called anterior fissure, anterior median fissure. Yes, it's really deep. Behind, on the posterior surface, there is a posterior median sulcus. It's already groove. Well, we divide spinal cord into right and left halves. They are symmetric. Afterwards, you see parallel to the anterior median fissure, there is one more sulcus that is called anterior lateral sulcus. The same on the opposite side. And in this sulcus there are roots. These roots are motor roots, and everything is developed during embryogenesis by the way when all that is motor is located in front, all that is sensory is located behind. Therefore, in front we have motor roots. Afterwards, in the posterior part, we find one more sulcus. It's already posterior lateral sulcus. And in this sulcus, one more root. This root is called sensory or posterior root. This one. Sensory root, it enters the spinal cord. Motor root, it exits. It goes out. Well, we divide the parts of spinal cord into trunks, which are called funiculus. Anterior funiculus. It's limited by the anterior median fissure and anterior lateral sulcus. Anterior funiculus. Lateral funiculus. It's limited by the anterior lateral and posterior lateral sulcus. And there is posterior funiculus. This posterior funiculus is limited by the posterior lateral sulcus and posterior median sulcus. This funiculus is subdivided into two additional fascicles. And to divide it, one more sulcus is represented here. It's called the intermediate posterior sulcus. It divides the posterior funiculus into two fascicles, gracile and cuneate. Well, we described the external surfaces of spinal cord. We can ask, okay, but what is the lower part of spinal cord? What had happened with the lower located parts? This end of spinal cord, so this is a level you should understand of the lumbar vertebra, second lumbar vertebra. There is an end of spinal cord. This part is called the medullary cone. It really has the appearance of the cone. From this cone, the terminal thread is located. It's called filum terminale. It's already not developed spinal cord. It's just the remains of spinal cord. It's rudimentary development. So this one, rudiment. We can see also that the direction of roots is different in the upper parts. They are located nearly horizontally, but by the way downwards, they are more or less vertically located. And to get the certain intervertebral foramen, the root should go down to get it. The complex of roots which surround ferium terminale, this complex of root, is called cauda equina. Literally means horse tail, but the medical term is the cauda equina. It's located already in the sacral canal. Internal structure. The transverse dissection of spinal cord is performed. We can see that in the central part there is a central canal. What is it? Little amount of cerebrospinal fluid. Very low amount. But it's here. Gray matter, or gray substance it's called, that is surrounded with white matter. We know it from the school course. What does it mean, gray matter, gray substance? It's formed by the nuclei. It means that the body of neurons formed body. These bodies are congested to form the nuclei. And the appearance of the gray matter resembles the butterfly, not everywhere, but only at the level of the thoracic segments, or the letter H, if it's in the cervical, lumbar, no sacral segments of spinal cord. It's divided into anterior horn, projected forward, posterior horn, projected backwards, and lateral horn. What is located inside? Inside the nuclei, as we said, and the development had happened during embryogenesis, and everything that is motor, as we said before, is formed in the anterior horns. And therefore motor nuclei will be located here too. Sensory are formed in the posterior horn, sensory nuclei. Here in the lateral, the intermediate nuclei or vegetative nuclei are formed. White matter is formed by the fascicles. They form the conductive tracts created by the axons of the neurons. Again, the conductive tracts are motor in the anterior funiculus, sensory in the posterior funiculus, and the both types of them are in the lateral funiculus. It's in general. Now, we'll use your copybooks and we'll create the transverse dissection of spinal cord. I will do it with a blackboard. You will do it on your copybooks.